Hello, everyone. I'm Paul Drabble, Senior Marketing Manager with Delta Q Technologies, part of the Zappi Group of companies. So we're approaching the conclusion of the final day of the Future of Electrification virtual conference. So thank you for participating and for tuning into this session topic, onboard charging for Class 1 and Class 2 lift trucks. Just to let you know, all sessions are being recorded, so you're available to watch on demand at everyone's convenience in the future. Questions from the audience really enhance the value of the session, so we encourage you to share your thoughts in the Q&A tab in the top right of your session window, and I'll bring them up at the end of the session. Note that your questions will be posted privately. With that, it's my pleasure to introduce Conway Hui, who is the Director of Sales Application Engineering and Customer Support at Delta Q Technologies. Conway, the session is yours.
Thanks, Paul. Yeah, I'm Conway Hui, the Director of Sales Application Engineering and Customer Support. I've been with Delta Q for over 16 years, so I've seen a lot of different technologies come and technologies go, and applications come and go as well. Today, we're going to be talking about onboard charging for Class 1 and Class 2 lift trucks, which is a relatively new thing, and we'll go over the reasons why. Where is the slide advance? Here's the topics for today. We'll go over the demand, or the increasing demand for onboard charging, then how you can make these electric lift trucks a bit more versatile for what we now want to do with them. Talk about some challenges and give you just a little bit of practical advice. Now, this session is booked for the full 60 minutes, but it's really only about a 30 to 40 minute session. There's about 25 minutes of material, and then we'll allow 10-15 minutes for any questions that may come up. So just to set your expectations there. Now, the situation that led to this talk and the knowledge within Delta Q is we had a customer and their customer who wanted to replace the internal combustion trucks with electric. The catch was that this was outside of a warehouse. I mean, there's already electric trucks in the warehouse, but outside the warehouse, out on rental, out on construction, out on delivery trucks, that is new because there's no chargers on the walls when you're outside of the warehouse. That's where in-warehouse lift trucks usually charge. They go to the charging room, they charge. When you're outside of the warehouse, you don't have chargers on the wall anymore. Now, the customer already had the lithium battery because they already had indoor warehouse trucks with lithium, but they now had to send these trucks out and connect them to the rest of the world. So where do you fit the chargers on board? What kind of plugs do you need? How much time do you need to charge? All these obstacles came up that Delta Q was asked to help with. So the stakes in this project were also quite high. There are regulatory changes, which we'll talk about, that are influencing these decisions. There's also sustainability initiatives that are influencing these decisions. Now, also personally, I also care about this sort of thing and converting internal combustion machines to electric. I'll tell a short story. For those who don't know, in my free time, I'm also an Army Reserve officer. And in 2021, we had a very significant, massive flooding event here in Southwest British Columbia that flooded an entire area of eastern Abbotsford. And so the local Army Reserve was called in to assist the local residents with flood mitigation, protection of their property. And it followed an already busy year of forest fire, a very busy forest fire season. So I went out there and led about a 120-person company of local Army Reservists, where we went out and helped people and saw how desperate they were to protect their properties and protect their livelihoods. And we saw the river levels, rivers that we know because we're all local, higher than we'd ever seen them. And so while I was out there helping the people who were affected by the floods, I was thinking, what else could I do to mitigate the floods and prevent this sort of extreme weather event in the future? And one of the things is through Delta Q, and converting more machines to electric drive and being able to use more renewable energy sources. So that's the reason why I'm here and why I'm interested in giving this sort of information out. So let's talk about the demand. One of the reasons for the demand increase in electric drive of non-road mobile machinery has been the stage 5 emissions, specifically for diesel engines in the EU. That's really restricted and cleaned up the emissions from diesel, and as a result made the diesel engines a lot more complex and more expensive, which makes the case for electric a lot more viable. We're also seeing a push from the California Air Resources Board to drive deployment of zero emission forklifts. There was a meeting back in March. There's some draft regulations out for zero emission forklifts in California. And as you may know, on the automotive side, what happens in California tends to kind of spread out through the rest of the country and the continent, really. So we're also keeping an eye on a possible future EPA Tier 5 emission for diesel. So if you're not aware, that's a good thing to look up, the different tiers of EPA emissions for off-road machinery. And that may also start to align with the EU Stage 5 emissions and really start to clean up the diesel emissions and, again, make them a little more expensive. So that's one major factor is regulatory. A second major factor that we're seeing is from the customer demand, the end customer demand, which isn't the OE, but the actual users of the machinery. They're getting more sophisticated. So they want less noise because of the environments that they're going out into, less maintenance, ideally less hydraulics, less engine oil, and all those other things that go with an internal combustion engine. But a lot of them now also have corporate sustainability goals that they want to meet by converting some or all of their fleet to electric drive. So that's another major factor, is the end users themselves. And this is the rental yards, the fleet operators, and so on. So the solution is obvious, right? We convert these Class 1, Class 2 trucks to electric and replace the internal combustion trucks. But these are happening, as I said earlier, in new applications, in rental, in construction, in delivery. Now, again, in many cases, the equipment manufacturers may already have a lithium battery, and switching from lead to lithium is already known to be a big step, and especially important for this outside the warehouse use case, because the lithium requires less maintenance, whereas before you may have had an entire room with lead acid batteries which you're servicing in a central location. Once you decentralize and you push these Class 1 and 2 trucks out, then less maintenance that the end user has to do on that battery, the better. And lithium really facilitates that. But once they leave that warehouse, again, they need to be able to charge anywhere. And that means putting a charger either with the truck or inside the truck on board, and connecting that onboard charger to existing infrastructure. And that could be whatever power outlets are available on the site. But we're starting to see demand to use existing charging connectors and infrastructure. So that's the first challenge. The first challenge is adding an onboard charger to an already very densely packed lift truck design. So you can't simply take the wall chargers like you see here off the wall and throw them on the truck. Those chargers aren't really designed for that. But at the same time, and a very important thing to remember is that a lot of times the wall chargers, maybe the ones that we see in the picture here, but even larger ones, they can be 10 to 20 or more kilowatts of charging uh, in the charging room for the truck. But once you leave the warehouse, you're subject to whatever power you have available on the site or wherever the truck happens to be. And this could be as little as 1.2 and typically maybe close to 6 or 7 kilowatts. And if you're really lucky, up to 10 or 11. And this is very similar to electric vehicles, what you find out there today. So that's one consideration, is how much power you actually have available out there in the world for these class 1 and 2 trucks. And also to size that pack accordingly. Like you can have your same gigantic pack, but if you send it out into the world, it may never get fully charged because you don't have the power around to charge it or the time to charge it. There's some other challenges involved with adding an onboard charger. One is ideally you want to integrate it fully with the lithium pack so that the controls and the BMS on the lithium pack send the charger the best information for the best charge. That could be temperature information. It could be a certain voltage set point, lower current or a higher current, depending on the condition of the battery. That's really important to do with the onboard charger. And if you like, a really good bonus, a lot of these trucks already have telematics on them, but bringing the charger into that telematic system is another really good idea. But the most important thing, the last one there, is you're now taking the charger off the wall outside of the warehouse environment, the temperature controlled, covered building, and out into the world where it could be subject to anything. It's probably going to see a lot of shock, being driven around, maybe driven over curbs, obstacles, on and off a delivery truck. Vibration, moisture, dust, heat, cold, all sorts of things that it might now be exposed to now that it's outside. So that's really important. The wall chargers in the warehouse are not really designed for that kind of usage environment. And the next challenge is what's out there? What is it going to plug into? Is it going to plug into the wall outlet? Is it going to plug into an EV charging station? What does that EV charging station look like? Where are they going to find an EV charging station? There's a lot of unknowns around what you're going to plug into once you leave the warehouse. So for North America, here's some charging connections you might see out there. The one on the left is a 208 volt North American plug. This one is a NEMA L1430, but there's a whole range of confusing NEMA Ls and 14s and all sorts of different 208 volt and 3-phase plugs that you might find. But in our experience, the L1430 is a fairly common one that you would find in construction, because people might be using it for welding or other tools. So the 1430, the 30 means 30 amps. Pull 24 amps continuously out of it based on the National Electrical Code's 80% guidance. So you're really looking at like 5 or 6 kilowatts of charging out of what you might most commonly find on a construction site. And then you have what we're probably all familiar with in North America, the NEMA 515, the standard wall plug. This is 110 volts, single phase, but you're really only going to get 1.2 kilowatts out of it, which in the world of kind of larger battery packs is a real trickle of a charge. And then the last thing you'll see more and more commonly these days is EV charging stations and the EVSE adapters. And we'll go into a little more detail of these in a second. So EV charging connectors seem to be the way that we want to go with class 1, class 2 outside, but also a lot of other machines that Delta Q deals with. Golf carts, floor cleaning equipment, other types of construction equipment, just commonizing on the EV charging connector. In North America, that's the J1772. Okay. And that one you see on the top there is good for level 1, which is single phase 110, 120 volts AC. And also level 2, which is capable of up to 19 kilowatts at 208. But most of the stations you'll see or have installed probably only will handle 7, maybe 10 or 11 kilowatts. It depends on the installation, but most commonly you'll see 6 or 7 kilowatts available. The other thing that's out there is CCS, which is the DC fast charging. It's just the same plug as the J1772 on the top part that you see there, but there's 2 giant pins for the DC direct charging, which is good for, depending on the socket type, up to 400 kilowatts direct DC charging, up to 1,000 volts DC. So we could charge 80 volt lift trucks with DC fast charge. If you have, for some reason, have like a 50 to 400 kilowatt fast charge station right by your construction site or at your rental location. Seems like it'd be fairly uncommon, but you never know. On Europe, in the Europe side, the CE77 and their kind of variations around Europe, most common 220 volts, typically about 3 kilowatts, which is almost 3 times more than the standard plug in North America. And again, also EVSE adapters, and we'll take a look at those for Europe and kind of rest of the world here. So the plug looks a little different for the standard EV plug in Europe and much of the rest of the world. It's called the Type 2 IEC 62196. And again, this is a mode 2 up to 7 kilowatts and a mode 3 with 3-phase up to 22 kilowatts. Okay, and Delta Q can help you if you think you can get 3-phase, but as I understand in Europe, it's somewhat uncommon. No,
but most of it is going to be
mode 2. And for fast charging side, very, very similar CCS to North America, the Combo 2, which takes the Type 2 port on the top and adds the 2 gigantic DC fast charge pins to the bottom. So you may see those out there. Very rare, especially for where a class 1 or 2 lift truck may be used. I'll come back to the questions at the end. I see there's some questions piling up in the Q&A. So finding space for chargers. Okay, now these lift trucks, if you were to look at a class 1 or class 2 lift truck, you'd find it pretty packed full of stuff, ballast, batteries. But what we found is generally switching to lithium, which is a more dense technology and chemistry, creates enough space to put some onboard chargers on. This really depends on the mechanical design of the truck, but sizing that battery down either by lithium, by going to lithium, or by going to lithium and then also sizing it down further should make some space for 3 to 10 kilowatts worth of onboard chargers like we see here. That's the Delta Q XV3300 on the right, a 3.3 kilowatt module. So if you put 1, 2, or 3 of those on board, you can get up to 10 kilowatts and should cover most of the cases of EV charging power and even temporary site power that you have available, which as we know, 6 to 7 kilowatts. And depending on your battery pack size, if it's like a 50 to 70 kilowatt hour battery, which is should be typical for a lithium conversion, that you're maybe looking at an 8 to 10 hour charge time, which is pretty reasonable. But if you only had 110 volts and 1.2 kilowatts, then you have a bit of a problem, because then you're looking at like a 30 to 50 hour charge time. That may be an issue if the customer is going to really deeply discharge that pack and use it a lot. But it's not just the chargers that you have to find space for. You also have to find space for that EV charging inlet. And this is where we came across some challenges, because we weren't sure, the customer wasn't sure if they wanted to have just the EV charging port or the EV charging port and then also a 110 connector and a 208 connector. So you have 3 sets of inlets, and trying to find space on the truck for all of that and tie it all together on the inside and switch between them. It just became overly complex. So really, we recommend, number one there, just focus on that EV style AC charge inlet and kind of the AC version of that, not the DC fast charge yet. Maybe someday we'll need it, but for now, let's just focus on that basic AC version. And the picture here is the standard J1772. And if we just put that in then we only have to worry about integrating that one thing. There are communication circuits on the inside of that, which you can then roll inside the onboard charger. Like the XV3300, it has that circuitry built in, but at Delta Q, we also have like an extra module just for that interface circuit with the EVSE. And then what you do is, because this is such a standard, for example, J1772 or the Type 2 connector, they're everywhere. EV adoption is really picking up. Here in BC, it's like over 10% of new car sales. There's good access to adapter cables from the J1772 or the AC inlet to whatever you're finding on the wall. The standard 110 outlet, the 208 volt outlets, in all sorts of connection styles, like the dryer connector that you might have, or the range or stove connector that you might have. And so there's adapters and portable EVSE boxes for all sorts of things. So those are going to be off the shelf and easy to replace. Now, the big thing that we also encountered was charge time expectations by the end user, because that is less dependent on the truck and less dependent on the charger and the charging setup than it is, like I said in the beginning, on what the customer has available at their site. If they only have a 110 outlet and 1.2 kilowatts, they're not going to charge that gigantic 50 kilowatt hour pack very quickly. And the customer, the end user, needs to be educated on, listen, if you have this plug, it's going to take this long charge. You need to find a 208 source or an EV charging station with 3 to 6 kilowatts to charge that pack in a reasonable amount of time, if you're going to be using most of that battery capacity through your workday. So this is really important, that the users understand that they can't just leave the truck somewhere for a week and expect it to charge overnight on a very small power source. So that's the bulk of the material I had for this talk. Again, the key takeaways were why electric lift truck deployments were growing, and we talked about regulatory reasons. We talked about customer and user reasons. The second point, matching the use case with the battery type, onboard chargers, and the charging connectors. what's out there, what's available, what these trucks are going to encounter in the real world, and the type of battery that you should be using, which the answer is just lithium. And using modular charges as well. So going 3 kilowatts, maybe 6, maybe 10. And lastly, again, I can't emphasize enough just educating the users on this new conversion from what they're used to, which was internal combustion, propane or diesel or trucks, and switching them to an electric truck and using it outside and having to plug it in. This is going to be all new for them. So really ensuring that they understand and have the right expectations of what that technology is capable of will ensure a successful deployment of electric Class 1 and Class 2 lift trucks outside of their typical warehouse environments.
Okay, thanks, Conway, for a great presentation. We do have a few questions that have appeared, so let's get into those. First question, what's the benefit of putting the charger on a Class 1 truck?
Well, like I said, if it needs to leave the warehouse environment, then unless you're bringing the wall charger with you and putting the wall charger up at the temporary site, then that charger is going to need to live on board the truck. It just offboard chargers, in other applications, I'll use floor cleaning as an example. They lose their chargers quite frequently, their offboard chargers quite frequently. So the floor cleaning world really adopted onboard charging quite readily because the charger went everywhere that the floor cleaning machine went, and they didn't have to go hunt through the whole building for the offboard charger that was left in some boiler room somewhere else in the building.
Okay, so following up on that question, should the charger be in the battery tray or on the truck body?
I mean, I don't think it matters. I think the battery tray is going to be a bit warmer of a spot, but the charger should be able to live in that environment. Relative to the size of the battery packs, the onboard charging levels that we're using are quite low, so they shouldn't heat up the packs too much. And so maybe after and the use cases we're seeing for outside the warehouse, they're not continuously running the trucks like in the warehouse. It's kind of ad hoc use, so the battery is not going to be as hot as it normally would be.
Okay, what are the charging requirements for onboard chargers?
Back in some of the earlier slides was the vibration requirements. So if it's going to live on the truck, it's got to tolerate everything that the truck is designed to tolerate. Now that includes vibration. The biggest we see is just driving over things, rocks, rough terrain, curbs, a lot of curbs, and having to deal with that level of vibration that a normal kind of on the wall in the warehouse charger is not going to be designed for. And that's the biggest thing, is vibration. Less so kind of weather, because it'll hopefully be under cover, but vibration and moisture, like in the form of salt fog or just high humidity.
Okay. What are the auxiliary voltage requirements on a Class 1 and 2 truck?
That varies from manufacturer to manufacturer. Some of them don't have any auxiliary systems at all. Like we're talking like a 12 volt or low voltage control circuit, or auxiliary circuits for instrumentation. Most of them do, but we've also seen a lot that don't. And maybe an important point that I didn't bring up during the talk is the EVSE interface. When you talk to an EVSE, it expects that the machine or the vehicle has 12 volts on its side. So in order to start talking to an EVSE and get it to turn on and give you AC power, it actually needs to, the truck actually needs to have 12 volts in order to initiate the conversation. So that can be either in the form of a small 12-volt battery on the truck powering the EVSC circuitry on the truck side, or a DC-DC converter that converts the 80 volts, for example, from the pack down to 12 so that we can switch on the EVSE.
Okay. It looks like the last question here. Are there any disadvantages of onboard chargers compared to offboard chargers?
In this use case, they're already using offboard charging a lot, and they're wall chargers. So you'll get more power in the same kind of space because they don't have to be designed for vibration. They don't have to be designed for environmental protection, and so they'll be a little smaller. They'll be a little lighter. So if it's known that that charger is going to live in the warehouse forever, then it's fine to have an unsealed, non-vibration proof charger. But the onboard charger, can be used anywhere. It could also be used in the warehouse, but it's designed to go on board as well because of its vibration and environmental protection. So we do also see warehouse environments that benefit from using an onboard style charger because it's a harsher warehouse environment. Cold storage is one that comes to mind. So if they want to keep it on board for some reason and have it go into various cold storage facilities, then having an onboard charger designed to handle those kind of conditions is going to be helpful.
Another question came in. What is the level of integration required for the onboard charger, and how is this different than an offboard charger?
I think they'd be the same because the integration is in the battery telling the charger what it needs. So the needs of the battery are going to be very similar. I mean, the outdoor conditions are going to be subject to ambient temperature differences. So definitely integrating temperature communications, and if the BMS needs different voltage or current due to temperature, that should definitely be communicated in an outdoor environment. But the actual data that goes back and forth should be very similar.
Another question came in. In your experience, do you recommend a liquid-cooled battery considering the environment and high current drawn in hydraulic motor and vehicle movement?
Yeah, that's interestingly a topic that we touched on yesterday in the Future of Battery and Charger Technology panel with Eric Staffel, and we had this exact question on the panel of where do we see, like, all the automotive and heavy duty truck batteries are fully liquid cooled, which means that they're not just liquid cooled but also can be liquid heated. And we talked about making that technology and that cooling, that temperature control technology scaled down into the slightly smaller packs that we see in our industries now. Class 1 and Class 2 trucks, they might benefit from some of that automotive level technology because their packs are larger. They get into automotive size packs, but not the automotive size voltages. So we're talking 50 to 100 kilowatt hour size packs. Putting a full liquid cooling or temperature control mechanism in that pack is definitely going to improve its life, just because of the amount of heat that is going to get generated. It doesn't have to be liquid cooling. Yesterday we talked about, and it's kind of a plug for the other thing, to go back and watch the video from the Future of Battery Technology session yesterday. But there's some other technologies out there. Luca from, I think, Zifan mentioned phase change materials that may be able to scale down and heat and cool a smaller pack. So that's going to be very important.
Okay. Their last call for any questions. But if it looks like that we're done here with questions, this does bring the 2023 Future of Electrification Conference to a close. This was the last session. So over the 2 days, we saw 1,200 registrants for this event, and some sessions. Well over 200 people attended those, so that's great. So on behalf of the Zappi Group and its member companies, I'd like to pass on our sincere thanks and appreciation to everyone that registered and committed their valuable time to tune in over the last 2 days. And we do apologize for some of the audio visual glitches that seem to surface over that time. But when things did run smoothly, we trust the agenda was what that we provided was relevant and engaging, and provide lots of value for your time there. So all sessions will be available on demand on the event website that we're on now for the next 30 days. Feel free to share that with your colleagues. And after that, the sessions will be available at zappigroup.com and the Zappi Group YouTube page. In the next day or so, we will send out an email survey, and would be delighted if you would take a moment just to provide your feedback and tell us about your experience over the conference, and perhaps any ideas and suggestions for improvement. And lastly, I'd like to send out a big thanks to our wonderful presenters, the panelists, and the moderators who made this event possible. So with that, I wish you all well, and hope everyone has a terrific week. So bye for now.